All right, so like I said, we're going to be looking at quadratic characteristics. Specifically, we're going to be looking at quadratics in the form in standard form. Sometimes this is known as vertex form. So what this means, when we look at a parabola or any type of quadratic, I'm going to have a vertex. That's either your minimum or your maximum. And we've talked about this. In this case, this would be my minimum. We know this is a root, and we know that this is also a root here based on this picture. Okay, so how does that help us? That helps us because in the standard form or vertex form, we can find our minimum and our maximum, as well as be able to write an equation of a quadratic using these characteristics. Okay, so you're probably wondering, okay, what is the standard form? The standard form for a quadratic is y equals a times x minus h squared plus k. So the a value determines whether the graph opens up or down. The a value also determines how close together your two lines are. So this right here and this could move closer together or further apart. It just depends on what your a value is. And we'll kind of look at some different parabolas so you can see the difference there. So also determines stretch of arms. Okay, then we have our vertex. Our vertex is at the point h comma k. Now something to note here, the h goes in opposite of what you see. So this is going to help us to determine, okay, where is our minimum or our maximum? This is known as our vertex. And how can we find our root or our zero? Sometimes you will be not in standard form, but you can find the vertex using your graphing calculator, and we'll talk about that in just a little bit. So to start off, let's say that I have y equals 1 x minus 3 squared plus 2. So based on this, my a value is 1 and my vertex is at 3, 2. And we're going to showcase this just by looking at our graphing calculator. This is not something that you need to necessarily write down and make sure that you understand the keystrokes for the calculator, but yes, you should write down this part. And we're just going to look at the a value and change it up a little bit. So if I'm on my graphing calculator, we had 1 times x minus 3 squared plus 2. Double check to make sure I did that correctly. So our vertex is going to be at 3, 2. And we can see that just looking at here, we're at 3, 2. Just in case you wanted to actually truly find it, you'd go to Menu, Analyze Graph, and in this case we have a minimum and not a maximum. So I do my left bound and my right bound, and that in fact is where my vertex is, which is good to know that we confirmed it in that sense. But just to show you some differences here, so this was our original here in blue. We're going to leave that there. We're going to make an F2. We're going to change this to 4, just so we can see what happens when we change that. Everything else is going to stay the same though. So notice here, As A value increases, my arms got smaller, so they came towards each other even more. So let's do another one of these. Let's say though that I want this at now a half, and then we'll do x minus 3 to the power of 2 plus 2. As you can probably guess, it was going to get wider. And that's because we're stretching that out. But let's say we make a negative. So let's go -1 times x minus 3 squared, and then we add 2. Notice, let's do that. Change that. Sorry, I meant to grab the label and it grabbed the graph instead. Okay, so we've got, just so we can see our order here to make sure it's correct. So notice when A was negative, it flipped the whole graph upside down. So this determines which direction your graph is opening. So if it's negative, it goes down. If it's positive, it goes up. When we increase the A value, that 4, our arms came closer together. When we changed it to a half, our arms spread out. Okay, so that just kind of tells us the difference between the two, and how those different characteristics can change what your graph looks like. The main thing from this is I want you guys to be able to find the vertex and be able to find the vertex even if it's not in standard form here. You can still find your vertex using